नमस्कार. आजच्या लेक्चरमध्ये आपण आल्डिहाइड्स आणि कीटोन्सच्या आणखी दोन रिॲक्शन्सचा अभ्यास करायचा प्रयत्न करूया. The two reactions with which we are interested today in this period, they are big D Canizzaro's reaction, that is self oxidation reduction reaction or self redox reaction, and E, a reduction of aldehydes and ketones by using different reducing agents. In the first instance, let us concentrate on Canizzaro's reaction, that is self-oxidation reduction reaction. Before this reaction, in the earlier period, we have studied aldol condensation, if you remember, wherein we have seen that that is aldol condensation, a reaction given by only those aldehydes and ketones which have an active alpha hydrogen atom, exactly contrary to this. Canizzaro's reaction is a reaction shown by those aldehydes which do not contain alpha hydrogen atoms. When such aldehydes which do not contain alpha H atoms are reacted with 50% alcoholic alkali, for example 50% NaOH, what happens is one molecule of the aldehyde is reduced to the corresponding alcohol and the second molecule is oxidized to the corresponding acid, more correctly sodium salt of the acid. Why? Because it is reacted with 50% NaOH, and hence instead of the acid we get an oxidation, sodium salt of the acid. For example, formaldehyde and benzaldehyde, these two aldehydes, they do not contain any alpha hydrogen atom, and hence of course they undergo Canizzaro's reaction, that is self-oxidation reduction reaction, that is self-redox reaction. Canizzaro's reaction, it is a reaction characteristic of an aldehyde having no alpha hydrogen atom. For example, formaldehyde and benzaldehyde show this reaction. When formaldehyde is warmed with 50% alcoholic NaOH, as I told you sometime before, one molecule is, we know very well that primary alcohols on oxidation give aldehydes, and hence aldehydes on reduction, they must give an alcohol. Similarly, aldehydes on oxidation, they give an acid containing the same number of carbon atoms. exactly the same thing happens in this case. Two molecules of formaldehyde I have shown over here. First molecule of formaldehyde and aldehyde containing only one carbon atom on reduction gives an alcohol also containing one carbon atom, that is methyl alcohol. One molecule of formaldehyde is reduced to methyl alcohol and another molecule is oxidized to sodium formate, that is sodium salt of formic acid, wherein both oxidation and reduction they occur in one and the same reaction. Hence the reaction is referred to as self-oxidation reduction reaction or self-redox reaction. Okay. We have seen in aldol condensation that benzaldehyde and formaldehyde, which do not contain alpha hydrogen atom, they never undergo aldol condensation. Now, contrary to that, we shall write down a note here that acetaldehyde and acetone, this is acetaldehyde, this is acetone, which contain alpha hydrogen atom. Acetaldehyde and acetone, which contain alpha H atom, do not undergo this reaction. Acetaldehyde, CH3CHO, contains alpha hydrogen atom, hence it will not undergo kinase reaction. Similarly, acetone, which has alpha hydrogen atom, it will not undergo kinase reaction. Thus, we have studied two reactions. Number one, aldol condensation, characteristic of aldehydes and ketones which contain alpha hydrogen atoms. And kinase reaction, that is self-redox reaction, which is characteristic of aldehydes which do not contain alpha hydrogen atom. Okay. The next reaction is E, reduction of aldehydes and ketones. There is nothing to explain in this because we have studied both of these reactions, 1 and 2, in alcohols, different chemical reactions of alcohols. Primary alcohols on oxidation give aldehydes, secondary alcohols on oxidation give ketones. And now in this case, aldehydes on reduction give primary alcohols and ketones on reduction give secondary alcohols. The reduction may be brought about. We have seen this in two different ways. Number one, by using molecular hydrogen gas in presence of ranenikel. Ranenikel also, I remember I told you, ranenikel is nothing but an alloy of aluminium and nickel. When that alloy is reacted with, treated with, leached with caustic soda, aluminium is vanished, it goes away. Only porous variety of nickel remains behind and is referred to as ranenikel. Acetaldehyde on catalytic hydrogenation using ranenikel as a catalyst gives the corresponding primary alcohol, namely ethyl alcohol. Similarly, the ketone, namely acetone, on hydrogenation, on catalytic hydrogenation with ranenikel as a catalyst, it gives secondary propyl alcohol. Now this reduction may be brought about not necessarily by hydrogenation and Rann-Nikel, may be brought about by using sodium amalgam NaHG. Sodium amalgam, we have seen, reacts with water, giving nascent hydrogen. And this nascent hydrogen brings about reduction. Reduction with sodium amalgam and water. Sodium amalgam and water. I remember I have given you that reaction also. NaHg plus H2O, NaOH plus H nascent plus Hg as it is. And that nascent hydrogen brings about reduction. CH3, CHO acetaldehyde, reduction, sodium amalgam and water as reducing agent, ethyl alcohol, acetone, reduction, plus 2H, sodium amalgam and water, secondary propyl alcohol. Now the next reaction is marvelous, something new. Because in these earlier two reactions we have seen how aldehydes on reduction either by using sodium amalgam and water or by catalytic hydrogenation in presence of Rann-Nikel, they give the alcohol, corresponding alcohol. Aldehydes give primary alcohol and ketones give secondary alcohol. But in this third reduction of aldehydes and these ketones, there is complete reduction of an aldehyde or a ketone to corresponding alkane. And this complete reduction of aldehydes or ketones is brought about by using zinc amalgam and alloy of zinc and mercury and dilute HCl, wherein we come across 4 nascent hydrogen atoms. A very good reaction. Acetaldehyde, now not 2H, now 4H. Acetaldehyde plus 4H, we get CH3 single bond CH3, that is C2H6, that is an alkane, namely ethane. Of course, plus a molecule of water. Acetone, CH3COCH3 plus 4H. Complete reduction with zinc amalgam and dilute HCl. It gives CH3, CH2, CH3 and alkane, namely propane. It's a very important reaction, asked many times. It is known as Clemens-Heinz reduction. It is known as Clemens-Heinz reduction. So, what is Clemens-Heinz reduction? Complete reduction of an aldehyde or a ketone to corresponding alkane by using zinc amalgam and dilute HCl as a reducing agent, wherein we come across 4H now, not 2H as in the earlier case, 4H. Acetaldehyde gives on complete reduction the corresponding alkane containing 2 carbon atoms, namely ethane, while acetone on complete reduction by Clemens-Heinz reduction, it gives an alkane, of course containing 3 carbon atoms, namely propane. We stop today.